Hello, everyone, and welcome to the Oxford University Press. Now, hello, everyone, and welcome to the Teachers E-Symposium by the Oxford University Press. This session is called Literacy in Computers. My name is Raheel Essa, and I'm an electrical and electronic engineer from the University of Liverpool, UK. Let's begin. The session outcomes are: we'll try to understand computer literacy, connect it with the curriculum objectives, and explore some real-world examples with multiple curricular linkages. So, think about this. What would you consider literacy in computers? I can name every component from a PC from ages ago. Is that literacy in computers? I know this hard disk from way back in the past had a data density of 100 bits per inch. That's like the length of a track, in a circular track. Now, does that even matter, really? Does it make any difference in our learning? I think these are the sort of things that might be considered further reading now, because we're all moving towards a situation where literacy in computers is more about the present and future. The past, yes, it can matter, but I think we should be a bit more selective about what we teach our children, our students, what we tell them, what we describe to them as, what is necessary, what's important. So, do you think that what we're doing, what we're teaching, actually is preparing our students for the future? Do you think it's absolutely true that what we're doing is preparing them for the future? Because think about it. Do they really gain that experience to help them in their future careers? The future careers that might not exist now? The future careers that we have no idea about? We don't know what those careers could be, right? Have you ever heard of AI integrity and maintenance department? It could become a thing. I think it's really time that we rethink what it means to be computer literate. So it is possible that future jobs are so focused on computing ideas and skills that it would seem pointless to learn about the history. Instead, you should focus on the current and future of computers. I'm not saying this is 100%, but at least that's what I feel. So I think it's very important that our education focus more on skills than on anything else, especially completing the syllabus. So I'll give you an example of a student's perspective on some things that are taught in school and how he thinks they're useful. Yep. He's really glad that he learned about parallelograms. It's also very important that the skills are developed and the concepts are made clear. And it's very important that misconceptions are destroyed. So you might have noticed that students will always keep asking you, what's this for? What am I learning? What is this for? How will it help me in the future? And when will I actually end up using this? What's its purpose? Why do I need it? So students will definitely not understand what they're learning unless the application is made clear to them. And if they don't understand that, they will simply fall back on rote learning. Right? It's important for teachers to help students understand the real world connections because it aids in cognition. The real world connections actually allow students to think about different scenarios, and it increases their knowledge. The more they know about more varied topics, the better they will be suited to jobs that do not exist yet. So it's funny, people have always said, they've always misquoted this particular saying, jack of all trades and king of none. But if you read the whole quote, it says, it continues on to say that better a jack of all trades than king of one. because, well, even people back in our past used to understand the importance of being flexible. The flexibility aspect is actually very, very important these days. Every company and every person has to be agile. So think about what that means. Like, in fact, in this current scenario, the fact that we're having this E-Symposium should give you an idea of why flexibility is important. And the fact that our schools are all shut down and we're having online schooling, it really gives you an idea of why you need, first of all, true computer literacy, these skills that are essential to run your computers, to run your online classes, the skills to use a computer, and the flexibility to switch between and jump back and forth between one type of teaching and another type of teaching. So an online-based system and an offline-based system, face-to-face, on-site, in-class system. If you're unable to actually do that, that means your lessons are not flexible, that they're very, very strict, very focused. And now it's good to be focused in a lot of situations, but yes, if you're focusing on one particular concept and you want to teach that concept, be focused. But make sure that you yourself as a person are flexible enough to modify that lesson, to work in multiple scenarios, to work in a different area, in a different environment. And that's where scalability actually comes in. So let's talk about some of the things I feel are, the skills that I feel are necessary. Office software. Now, we all know how to use Office software to a limit. I've met people who are in pretty, important positions, and the only Office software that they really use is Outlook. So, because all you do all day is email, right? And they will occasionally use Word, but they might as well be using Notepad at that point. Well, I say Notepad, I mean, let's say WordPad, because you'll just be changing the font size, you'll just be changing a little bit of formatting and bold some stuff, italicize some stuff. You could just use WhatsApp for that. You don't really need something like Word. But if you truly want to use Office software, you have to know how to use not just one. So I'm not just talking specifically about Microsoft Office, but how about these other types of Office softwares? So there's OpenOffice and there's LibreOffice. And apart from them, obviously, we know about our Microsoft versions and Google versions, which Google Office works online completely. And there are some other versions of OpenOffice that also work online. And Microsoft Office now also works online. So you can move to a cloud-based system, but you have to understand your context. So those are all the icons of different Office softwares. So it's important for all students in schools to understand how to use basic Office software. And it's also important in future, of course, because I don't think the keyboard is going anywhere soon. You're not going to be switching to virtual reality anytime soon. And in some instances, it's also useful to learn more advanced softwares. So then we move towards the concepts of vocational training. And well, while that's different, it can be useful. We are shifting more and more, like in our world, in a model where vocational training is actually more important than your generalized training. But at the same time, there has to be a shift in the generalized training for it to actually remain important. So let me put it a different way. Our generalized training is archaic. The methods were designed for the industrial era, for the industrial age, and they haven't really modified themselves. Like, we haven't modified them really since. The whole layout, the fact that, okay, you have to be taught discipline. Now, I've been to classes where there's a hell of a lot of noise. And, the teachers would be like, oh, these kids are rowdy, or, this teacher is not able to maintain a class discipline. But I noticed that that is when that class was able to learn more than when they were disciplined, when they were sitting back. And reminds me of John Dewey's quote. When John Dewey was looking for furniture for his school, um, he went around to many different shops and he kept looking around, and he spoke to his colleagues and said, I can't find any furniture for my school. And they were like, what are you talking about? There's so much furniture available. Look at this place, this place, this place. And he said to them, well, that's all furniture that's designed to make students sit and listen. And I think that tells you quite a lot about our education system in essence. Right? So it's very important for us to be contextually aware of our situation. So if our context doesn't really allow for very generalized knowledge, then we should focus on the vocations. Because let's say, we're living in a country like China, and the biggest jobs are provided in the manufacture of some electronics, or not even manufacture, more like assembly line of electronics. A lot of people over there go and get this vocational training of how to assemble those electronics, how to work in those specific factories. Foxconn comes to mind, obviously. But there's many different examples similar to that. So there'll be countries where there's a lot of mining industry, so you'd want to be educated in that particular scenario. Or there's countries where there's a lot of tourism and a lot of restaurants and a lot of other service industry, so you'd want to be educated in that area, because if you want to live in that context and you want to flourish in that context, then you should know about everything that goes on there and how to actually survive in there and sort of grow in there. But at the same time, the general aspects should still remain when it comes to your lower education. So it's still important to be able to adjust yourself and be flexible. So connects well back to what I said earlier about how we need to change our systems, our education systems. So let's look at something else that's more tech related. We heard of Linux. Linux is the future. In fact, I dare say Linux is the present, because Android is based on Linux. In fact, so is iOS, and Linux is slowly being integrated into Windows with what's known as Windows Subsystem Linux. And my focus is to use this to its fullest, and in fact try and educate students in it as well, because even macOS and iOS are all fundamentally similar to Linux. They have a very similar underlying kernel. Kernel is kind of well, it's complicated. It's what the operating system on top, the front end, which we interact with, connects to the hardware with. So if you think about this, the fact that Android and iOS and macOS are very similar to Linux, they are basically the same fundamentally. And Windows is also adding Linux. You have to realize that, yes, we should all know about Linux, we should know how to use Linux, and we should definitely be aware of the nuances of it. So it is my understanding that, or rather my prediction, that Windows will most likely be sort of combined with Linux in the future. And Windows is like the most popular desktop operating system right now. And we are slowly migrating towards more easy to use operating systems. If you look at Windows 7, you look at Windows 10 now, they have the same name, but Windows, but they're very different in how they are operated. They're slowly and surely becoming further and further apart. And it's important to adapt to these changes. The reason why these operating systems are becoming more and more simple is because that's what everybody needs. They want to focus more on getting the work done rather than tinkering about in the guts of the operating system. So in the future, when it's possible that Windows just becomes a virtualization layer on top of Linux, then, well, you could, if you want to, tinker around in Linux. So you should know a little bit about Linux. But then again, because Windows is just going to be running on top of that, you could just work on Windows, and Windows will be pretty simple um, in that future scenario, because by then we'll have Windows 10, 10X, or whatever it's going to be called, and there won't be any control panel. It's just going to be a settings menu. It's just going to be very easy to use, even on a touch-based computer. And you will look at Windows and you will look at Android and you'll just be like, they're quite similar now, because one will run desktop apps a bit better and one might not. And maybe in the future, Chrome OS will become like the standard system, because hey, it can also run Android apps. And in fact, there was some news earlier that Windows is getting access to Android apps. I don't know how verifiable that is right now, because the same thing was said a few years ago and didn't seem to pan out. You can still emulate, but emulation is quite different from virtualization. So now let's think about the sort of stuff that can be considered useful in educating students more about computers and computer literacy. So there's a Raspberry Pi. It's a single board computer, right? And it comes in many different varieties. You can get the Raspberry Pi 0 or the 0W. The W stands for Wi-Fi, so you have some wireless capabilities in that. It's really, really tiny. It's like you have the Pi 4, which is the size of a credit card. It is literally the size of a credit card, if you look at that. That is. And this is the fourth version of the Raspberry Pi, of this shape Raspberry Pi. There's the Raspberry Pi 1, 2, 3, and 4. But in between, you had the 0 and the 0W, which are just small versions, very small, and they're low-powered versions, and you can use them for IoT, Internet of Things aspects. And I would prefer to get the one with Wi-Fi, obviously, because Internet of Things, yeah. So there's also the Pi 400, which is an excellent computer. It actually comes inside a keyboard. So if you've seen the Raspberry Pi keyboard that comes from the Raspberry Pi Foundation, it looks identical to this. The only difference is this one has all the ports at the back, including this. So this is the GPIO, the general purpose input output, and there's the micro SD slot, a bunch of connections over here. You can connect your USB devices and Ethernet if you want. This is actually the board. You can see the board here. They all run Linux, of course. Why wouldn't they? Linux is the future and the present. Now, there's also Arduino. Arduino is quite different from Raspberry Pi. While the Raspberry Pi was a single board computer, this is a microcontroller which can be programmed with C code. And well, you can use different codes on it. The Raspberry Pi uses Python, right? So this is an excellent tool to learn programming. I mean, this particular one, the Arduino Uno, you can get it for I think around 400 rupees, and of course it's not the original Arduino, not from the same company, Arduino Foundation, I think. I'm not sure, I can't remember. But regardless, you can buy it for 400 rupees, and for 400 rupees, if you have like a class of 15 and you just buy, let's say you buy 7 of them, get everybody shipped, 8, put it that way. That's not a big cost. What is probably a big cost would be actually having computers to connect this to and program it with. But then you could have Raspberry Pis, and the Raspberry Pi 400 in the keyboard comes for, I think it's $70 US. Not really that expensive. You will need a monitor with it and a mouse, of course. Well, monitors are not that expensive. You can get one for 3,000 rupees. So this Arduino actually comes in multiple varieties. So you can see the tiny one. Here's the Arduino Nano, and here's the Arduino Mega, and this is the Uno. So microcontrollers and single board computers, both of them are excellent to prepare students for a future directed by technology. So they look pretty technologically advanced, right? You got your circuit board right there. It's a bare circuit board in both situations. In both situations, you have these um, it, these connections, these are called the general purpose input output, and you have them over here on the Arduino as well. Look at them. You can learn how to use Linux and open source software, including even Office software on the Raspberry Pi. Right? You can learn how to program things in Python. You can do the same with Arduino. You can learn more complex languages like C. And they both can interact with the world through sensors, thanks to the GPIO I was talking about, the general purpose input output. This really assists in connecting with real world concepts. So it also has the ability to be integrated into different subject curricula. So it's important to actually do that, to connect with different subject curricula, because students are like they're very capable of learning multiple things together, but our education system puts them in situations that's very, very focused. So when it's there's like boxes of different subjects. So, oh, the computer class is over, let's close that box, put it away. Now let's open the Urdu box. Okay, let's open that. Yeah, now we're in the Urdu class, let's work in the Urdu realm. They're isolated subjects, or history or geography or whatever. Insert your favorite subject here. But with this, you can connect it. You can connect geography if you want, geology if you want. You can connect science easily. You can connect mathematics. And, well, it could be pretty excellent in terms of for the learning of these students. So there are many other options available. You don't have to go for specifically the Raspberry Pi and the Arduino. There's in single board computers, there's stuff like the BeagleBone and there's an Intel version of it. There's also an AMD version. There's the NVIDIA Jetson, I believe that's what it's called. And instead of Arduino, there's many other variations that all work sort of similarly. And you can actually use the same Arduino software to program them. And there's even web-based versions of programming softwares available. And there's even block-based softwares. So if you have access to a computer that has a web browser and can connect to anything with USB, right, then you can actually use that computer, even the Raspberry Pi, to program the Arduino using block-based programming, using some form of Python, C programming, C++ if you want. There's even, I think, a C# version. And I would have absolutely loved to have these available when I was a student. So what I had was this thing called a basic microcontroller. So the fact that these guys are free and open source, that makes them really affordable. So the Arduino, as I said, was 400 rupees. The Raspberry Pi you can get for, I think, $35. So it's about current exchange rate, 5,000 rupees. I don't think it's available for that cheap in Pakistan though. So, but still, a basic microcontroller, the cheapest one that you could get back then, that was in like 2007, 2008, was I think $50, and that one was absolutely trash as well. So it didn't have nearly as many options as this Arduino. And this Arduino is, of course, way more powerful than the computers that took man to the moon. So go figure. I'll give you some examples of how you can connect it with different subjects. So you know about hydroponics, right? We actually do teach hydroponics in school. You're wondering, do we really? Well, think about it. We don't use soil when we're growing plants, but we do use water in this, right? There's your little seedling. It's in the cotton. It's just got water on it. So you could, if you want, to connect it to smart plant systems, right? So let's say you have your Arduino over here, okay? You got your some circuitry over here, and you've got these connections over here to the motors, which would be connected to the pumps or the valves, right? So they could pump water in and pump water out when you need them to. You could have, rather than a motor, you could use a servo that could just operate a valve, and you could use some form of sensor, right? And a bunch of indicating LEDs, as you like, as and when you like. So, and depending on the class, so if it's like class 5 or class 8, you could adjust the levels of the technology that you're using. So if you look at this one, here we have an OLED screen. Now, if you want, you could use this at a lower age, but then you would actually have to think about how you will structure that lesson. So I'm connecting hydroponics to electronics, to computer literacy. And I'm not going to want them to be totally overwhelmed and focus too much on the computer side. So I'm just going to give them snippets of code. So keep it in sort of a black box approach, right? Snippets of code that already work, just have to place them from here to here. So let's say you're in class 5 or class 6, you don't know what code really, you don't really know how to work with code. It's quite difficult to work with code. So you'd want to use something like that, little snippets of code. And by the way, that's kind of how everybody works nowadays, even like experienced coders. Most of coding is just copy paste, isn't it? So here you can have your Arduino, right? And you can have a pH level sensor, right? So you can test the actual pH values. You can have a light sensor that can tell you where what the level of light is coming on the plant at that point. So sunlight, and based on that, you can have a separate light that shines on the plant to give it the maximum amount of light. There's the humidity sensor, so you can sense the humidity in the room where you are, in the environment you are. And this here is, it says water level sensor. It's actually tests the moisture in the soil. So you can dip it in the water and you can actually test that. I'm not sure which version this is, but there are different versions you can get. I personally prefer using the capacitive one because the other ones tend to corrode a bit, so they might be cheaper, so you could consider them consumables, but that think of the planet. Yeah. So anyway, this is just a little conversion board, so that like an adapter, so you can give the power to this board. So if you wanted to, you could also have these electronics in black boxes, but then students will not be exposed to this, the actual electronics. It would be better to have them in, let's say, white boxes. You could see through them, transparent boxes. So you could actually see the electronic components. Now, I remember when I was younger, I used to want to know how all my toys operated. So I had this remote control car and I wanted to see what's inside. So then came a point where I could open things up and then I could put them back together. But every time I would open it up, I would look at these components and I would just feel intrigued. I had no idea what they were back then. I remember being confused, but I also remember not being able to find out what they were because, well, we didn't really have internet, or if we did, we didn't really have much access to computers or much information. And nobody that I asked had any idea what these things were. So all I found out is that there's capacitors and resistors. And even then, I didn't really understand that, of course. But if you expose students to these things at a younger age, then it's pretty useful. And you also have to think about the fact that I have not seen a single institution. So, as far as I can tell, there is no institution that teaches O-level electronics in Pakistan. I haven't seen one. If there is, please shout out, let me know. I'd like to connect. So you can adapt this project to fit more geology and geography centric topics if you think about it, because you have the humidity sensor, you have the light sensor, and you have pH sensor and soil sensor. So you could use it to actually measure different types of soil, if you wanted to. There's so many different ways you can use the same circuit if you want, just by altering the code. And once again, for younger ages, use snippets of code or pre-programmed devices with just slight modifications. And what I think is really awesome is when you're in, in your chemistry class and you have different flasks of different acids and bases. And when I was younger, I only had access to the pH paper, the litmus paper that either turned red or blue. So it came in either red or blue varieties. So if you had a blue one and you put it into whatever makes it blue, I can't remember. it'll stay blue, and you can't tell. It could have just been water, you know. So you have to put both of them in that unknown liquid. Now we have pH paper, which actually changes color, like complete color. And I think we used to have pH, some liquid, an indicator liquid back then, but it was expensive, so our school deemed that no, we're not going to get it. But that pH paper, you get a you dip that one. It comes in a single, I think it's white color or something, and you dip it in any liquid, and it'll tell you the pH straight away by a range of colors. It's a gradient of colors, and you can put it in front of that paper, and you can see, okay, so this is around a pH 4. Okay, so it might be citric acid or something like that. But when you have something like this, a pH sensor, you can actually get the exact pH value, the numerical value, and you can connect it to that piece of paper rather than saying, oh, it's around 4, it's actually 4.26. So you know the power of hydrogen then, right? Oh, as I was mentioning, you can measure air temperature, humidity, soil moisture, pH level, sunlight, and even UV. So UV is quite important thing to measure, don't you think? Because if you know how much ultraviolet is hitting your body, you know how dangerous it is to be outside for long. And what SPF value sunscreen you should be using. You can add your own lights or water pumps that run based on sensor values. And that's the best thing. You have sensors, so you can basically teach automation at a pretty young age. And then you have already educated students about currently available jobs, at least high-level ones. Right? Let's think about light and color. The idea that light is made up of 3 primary colors is shown in pictures, or if you're lucky, the teacher comes in with 3 different lights, or a box which has the 3 lights, and you can just turn the lights on, all 3 of them at different times. And you can see that there's the red, there's the green, and there's the blue, and in the middle there's like this little Rolo triangle that's made up of all 3 primary colors, and it looks white. And that's always been pretty fun experiment, pretty nice experiment. Well, what about light intensity? You know, we've never seen like torches that come with different brightness levels. If you have, you're lucky, of the lucky few. So if you can change the light intensity in those 3 different bulbs, then you could actually see the transition between the different colors. And let's say you have red and blue, and in between you have like a purple. So you could reduce the amount of blue and make it more reddish, more bright red, and you can adjust that. How would you do that with like normal torches? Well, you could just use a microcontroller or a single board computer, and you could connect them to the bulbs like so, and you could adjust the brightness by using what's known as pulse width modulation. That's PWM. And the Arduino Uno is fantastic for that. The intensity of light is not just important in understanding the variation in the colors over there, but also it connects with the future skills of image editing, right? If you think about it, because the screen that you're watching me on right now is displaying every color over here by using the 3 subpixels, red, green, and blue. So if you're seeing this red color over here on this little LED, that's because the green and blue pixels, subpixels, are actually off on in that area. So let's take a look at how to connect it to mathematics. So binary is something that we're always told about. Oh, you know, in computers, everything happens in binary. Everything is in ones and zeros. But it's difficult to understand. So we never truly explain that it's actually like a switch being on and off. Or even if we do, it's not made like completely clear. So a switch being on and off, just what we say, but how does that actually translate? So if you use a setup like this, where you have a bunch of LEDs, okay, you could have any number. Let's say if you just use 4 LEDs, you could have a 4-bit value displayed over here. And you could ask students that, okay, can you just read the value? And you can create, like put a little snippet software inside, and you can connect it with a method of adding the data into it using some commands. And if you just put in 1010 and it shows up, let's say 1010, and we hide these for whatever, then students can see that the LEDs over there and see that they're on and off and on and off, and then they can write that down, and then they can calculate, connect it with the tables of binary, and calculate what the value is actually, right? And it is the biggest issue that students have with understanding binary and actually connecting it with physical hardware. And you can use a microcontroller unit or a single board computer for all the experiments I've mentioned above. Okay, they're not limited to one or the other. Arduino has analog inputs and outputs that most single board computers don't. So analog input outputs means that you can actually use the Arduino as a sort of low voltage voltmeter if you want. Like, I think it's up to 10 volts, you can take that input. So you can test your batteries if you really want to. But you can do so much more than that, of course. I'm just giving a most basic example. It's also important to remember that all programming involves some kind of math. But don't worry, math is not terrifying. It's actually, it can be a lot of fun if taught in the right ways. So binary is a kind of math, and you talk about Boolean algebra. You do teach that in O levels, I'm sure. And this is a great way of visualizing some of it. So, generally speaking, literacy in computers is knowing how to best use a computer in the situation one finds themselves. The literacies are actually firmly linked with 21st century skills. And those skills are critical thinking, communication, collaboration, and creativity. Okay? You know that critical thinking is just solving problems, communicating and understanding and communicating ideas. Collaborating is working with others. Of course, you will most likely be working with others, as I mentioned earlier, that you can buy 7 or 8 Arduinos for a class of 15 or 16 students. So you would want pair work, because obviously that's how to get students to learn different points of view. And creativity, producing high quality work. So that's actually our final aim, as always. Let's take a look at the other 21st century skills. There's information and technology, and there's media. So information is how to gather and use information. And I think computer literacy does really involve that. Technology, well, of course, because it is information technology. And media, how to use, not how to consume media. Everybody knows how to consume media. How to use and how to create media. And finally, the life skills. As I mentioned, flexibility. There's leadership. If you want to work on this, you can use project-based learning. There's initiative. So, well, you can see how students actually create their own work, what initiatives they would want to choose and show to create their own high-quality work. And then there's the social aspect and productivity. Finally, there's the recommended books, right? Write Byte series. Thank you for attending, and goodbye.